And when you're down at part per billion, part per trillion level, you eventually find everything is contaminated by everything else. Right? Well, we do find 3 parts per billion. That's a very small amount. However, just because it's a small amount does not dismiss the possibility that it might be harmful, because there are substances that can be harmful in those kind of concentrations. If you think of something like botulin, terrible poison produced naturally by a bacterium, but at a concentration of a few parts per billion, that can kill you. So just the fact that the antimony is there at a very small concentration is not enough to dismiss the risk. What we need is a comparison numerically to what we know is potentially a problem. And we do know this because it has been studied. There's data that's collected in Canada by Health Canada, in the US by FDA, and we know that the acceptable daily intake of antimony in any water that we consume is about 6 parts per billion. This has been determined from studies, most on animals, where they're given increasing doses to see what the effects will be. The ADI has a huge safety factor built into it. And what it means is that if every drop of water that you ever consumed in your life were contaminated to the extent of 6 parts per billion with antimony, there would be no effect. So this is the acceptable daily intake because it doesn't lead to any problem. Of course, what we have in this water here is less than that. So even 6 parts per billion is not an issue. Certainly half as much is not an issue. There are plenty of things to worry about in terms of bottled water. Antimony is not one of them. The biggest worry is that this stuff is not being recycled. The plastic that we use here is not being recycled. Only 25% of all of these bottles are being recycled. That's a crime, because it means that we're using up a non-renewable resource, petroleum, to make new bottles, which isn't necessary. And then, of course, there's also the question of whether or not we should be drinking bottled water anyway. Is it enough of a difference from tap water to create this expense and this tremendous polluting industry, which is what the bottled water industry is? Well, of course, you can never say anything with 100% certainty, but pretty close to 100% certainty that this is one of the biggest scams that ever was perpetrated on the public, to sell something that's available for free for outrageous amounts of money when the risk level of difference is insignificant. So numbers are important. 500 years ago, Paracelsus, the famous alchemist, physician, philosopher, told us, sola dosis facit venenum. Only the dose makes the poison. That's the cornerstone of toxicology. We have to know amounts when we talk about risk. Let me give you an example. A very interesting compound here. It's a methyl mercaptoketone, for those of you who are chemically interested. But what is interesting about this compound is that in very small concentrations, it is responsible for the flavor of Cabernet Sauvignon grapes. If you are exposed to higher concentrations, it's the flavor of cooked meat. In even higher concentrations, it is the aroma of cat pee. Exactly the same compound. Different concentrations have different effects. So numbers are very important. They're very important whether we're talking synthetic compounds or natural. The term natural is not synonymous with safe or benign any more than synthetic is synonymous with danger. There's no such equation. For example, if we take a bite out of an apple, let's do that. Let's take a bite out of that apple. You know what you're tasting? You're tasting a huge collage of compounds. Here they are. These are not pesticide residues. They're not additives. These are the natural building blocks of that apple. That's what the apple is made up of. Over 300 different compounds have been isolated from apples, including some interesting ones, like acetone. That's nail polish remover. right? The last time you encountered that was on the label of your nail polish remover, right above where it says, do not drink. Also in the apple, we have formaldehyde. You know what that is? That's embalming fluid. It is toxic. Formaldehyde is toxic. We try to stay away from formaldehyde, and yet it's there in our apple. So I could scare you. I could tell you, did you know every time that you take a bite of an apple, you're getting some acetone? That's a toxic compound. You're also getting some formaldehyde, which is also toxic. Both of these can kill you. However, in this case, because of the formaldehyde, it's an economical way to go because you'll be pre-embalmed. It would be absurd to suggest anything like that, because the amount of acetone present in that apple and the amount of formaldehyde is trivial. It doesn't cause any problems whatsoever. The same way, pesticide residues can be present in amounts that are equally trivial, and yet people worry about them. So numbers are really critical, that apple isn't going to kill us because it has acetone or formaldehyde in it. Quite the opposite. The beneficial compounds greatly outweigh any of the risky ones. So the bottom line here really is that there are no safe substances or dangerous substances. I'll tell you, you want to know real danger? I'll tell you a real danger. The stupidity that they did out here on University Street, building that bike path, is going to kill people. I have seen on repeated occasions, not in the summer, but during the school year, when the ambulance could not get by here in the morning, when the school buses were all stopped in front of the school, and of course everything is narrowed down to one lane, and the ambulance was sirening away, it couldn't get by. It was absolutely ridiculous to build this bike path here with a divider this wide, a cement divider. Why on earth do you need a cement divider that wide? Make it this wide, or put in the poles like they did on Maisonneuve. This is sheer lunacy. It's going to kill someone. And then, of course, there's going to be all kinds of hand-wringing about why this has happened. So that's a real risk. That's something that something should be done about. Anyway, aside from that, there are no safe substances, only safe ways to use substances. And that applies to all chemicals. But it's hard to get this message across to a public that is not scientifically equipped to accept it. I'll give you an example. Playing telephone. You may remember this when you were small. You whisper something into someone's ear, and by the time they tell it to someone else, and then they tell it to someone else, the message that comes out is very different from what originally was said. And I experience this often. I say things, on the radio, and then I hear back the next day of what I said from someone. And of course, it was not what I said at all. It has gone through a few people. I'll give you a fascinating example. One day I was talking about a red dye called cochineal red, which is a very interesting dye. And I described how it is used in coloring strawberry ice cream, how it is used in coloring maraschino cherries. It's a very interesting dye, and the reason I told the story was because of the origin of this dye. It's actually isolated from little insects. These tiny insects, called the cochineal, are raised on cacti, mostly in the Canary Islands and in Mexico. The female of the species produces a red dye, and this is the red dye that is used to color strawberry ice cream or cherry ice cream. I told that story describing that this is one of the safest dyes. It has undergone all kinds of testing, etc. And I described the little insect. I said it was smaller than a cockroach. Probably not the best analogy, as you'll see. I get a letter from a lady who wants me to confirm in writing, after I described the story of the little insects that's smaller than a cockroach. She wants me to confirm in writing that there are cockroaches in chocolate ice cream. She heard the story, okay? I had never mentioned chocolate, never. But chocolate is brown, cockroaches are brown. She remembered that some insect, cockroach, connection, brown chocolate. She put 2 plus 2 together and got 5. And all of a sudden, chocolate ice cream is colored with cockroaches. It isn't. These are the kind of mistakes that people make because there just is not enough general scientific education. Life is full of risks. There's no question about that. You can be out for a casual little walk, right? And it can cause a tragedy. Oh, don't worry, we're not bad people, we faked it, they're fine. But they are not the innocent little creatures that you think that they are, right? So no matter what, there's always some risk. You substitute one risk by another, you may get a bigger risk. It's always a question of risk versus benefit. And you never know what new risk you're going to introduce when you eliminate another risk. So when you hear talk of bisphenol A having to be replaced by some other substance, we better make sure that whatever we're using as a replacement is better and safer than what you're replacing. We don't want to go into the fire from the pan. Right? The bottom line to all of this, as you might guess, is the need for more scientific education. We need to do this from early on. We need to do it in our elementary schools. The same way that we expect our kids to be literate, to be able to read everything. We should also expect them to be scientifically literate, because these days that's imperative. We make scientific decisions all the time. We need the weaponry to do that. We need to educate them through high school with science, and of course also through university. It's part of overall culture, overall education, to be familiar with what molecules are, with risk analysis, with numbers. Unfortunately, we're not doing a great job at it. We have to emphasize to students where our knowledge comes from, why we rely on the peer-reviewed literature. Not that it's perfect. Of course there are mistakes. We know that paper by Andrew Wakefield published in The Lancet, which scared people away from vaccination, which turned out to be totally fraudulent, was published in a peer-reviewed journal. Because of course the peers, that is the referees, don't do the work, they don't check, they don't go into the lab to check it. You have to assume that whatever the researcher is saying is true. That's what you peer review it on. So it's not a perfect system, but it is the best system that we have. And this year, it being the International Year of Chemistry, I think it is more important than ever to be out there talking about these kind of issues. International Year of Chemistry is a project of the United Nations. And the idea is not to be uncritical cheerleaders for chemistry. Not to say that, all chemicals are good and that there are no problems here. No. The idea is to explain what chemicals are. Sure, there are problems. There are skeletons in our history, in our closet. There certainly are all kinds of stories, not going back all that long, when waste materials were improperly disposed of. Today, things are very different. That story needs to be told. Chemists are not different from other people, contrary to what many think. It's just that I think we have a pretty good idea of how the world works. And we need to get that message out there. Everything in the world somehow relates to chemicals, because everything, of course, is composed of chemicals. And no matter what field of life you're in, whether you're in medicine, whether you're in engineering, or whether you're a librarian, you're always going to need some chemical knowledge. But science does not have the answers to everything. And it would be arrogant for us to suggest that we do. We live in a very, very complex world. We don't have the answer to everything, but we must endeavor to try to get them. And the way to do that is through proper education. But I suspect that what I've said here today may raise some questions. Not all of the questions can be answered. Some never will be, because they're just too complex. But if any of you do have any questions about what was said, I'd certainly be happy to entertain them. And let me just call attention to our websites. These are designed for everybody. so that if you're interested in science, interested in interesting things, you can check them out, oss.mcgill.ca.